And I want to make it clear that the teams that are coming up with these systems are not scientists who have been working in the lab for years. They're high school students or university students. And to make it even more clear, we've got one of the teams from RMIT who developed a project last year. Where are they? So we've got Hiwat and Michelle from the RMIT iGEM team, and they're going to be telling you about a project that they worked on last year. Okay.
Okay, so as Jeremy said, I'm Michelle and this is Hewitt. We were part of the RMIT iGEM team last year. Okay, so basically, peptide libraries are a fundamental part of the pharmaceutical industry when they want to make peptide drugs. But the problem with this is that it is very expensive to make. It costs millions of dollars and it's very time consuming. So we wanted to come up with a solution, and our project pretty much just utilizes a platform technology that allows for the rapid production of these peptide drugs at low economic costs.
Okay, so I'll skim through the basics of what we did. So to solve this problem, our project was aimed in designing a carrier protein for a peptide. And so this carrier protein would then be used as a platform for peptide expression and purification. So the carrier protein that we used was Taq polymerase. Now, Taq was originally identified in a bacterium that was naturally found in hot springs. And because of that, it has characteristics that make it thermolabile, it enables it to withstand temperatures that exceed 95 degrees. And as a polymerase, it also has the ability to bind DNA and also has catalytic activity. So to use this as a carrier molecule, we had to incorporate a few mutations to inactivate these two components of that protein. Okay, so what the platform consists of is a part where you would be able to insert a peptide, your sequence for the peptide of choice, and next to it would be Taq. So once after incorporating it into a cell, you'll be able to express high levels of this complex of the peptide Taq, and by utilizing Taq's thermolabile properties, you'll be able to purify it by just heating the whole culture. And once purified, after a process of cleavage, you'll be able to separate your peptide. And so this is just really just a simple mechanism of producing peptides cheaply.
Okay, so as mentioned, to make these libraries, it costs millions of dollars, which then rolls onto the consumer. So the drugs become very expensive to buy. So basically what our system can do is it can be adopted and enhanced to produce these drugs cheaply that can then be given to communities who can't afford these drugs at the price that they're currently at. Yeah.
So did you patent this work? Like, are you super rich now?
Well, we didn't exactly get enough time to finish this whole thing, so we designed it and got about halfway through the experimentals.
So what are you here for? Why aren't you working 24 hours a day?
We ran out of funding and all that stuff
And
at
time,
uni
so-
and time, so we couldn't
Don't you get
finish
a venture
it.
capitalist to fund you? I mean, it sounds like you're on hotcakes.
Yeah, well, if it worked, like if we finished it, it would have been very good.
Really good. At least a paper for us.
We started to write a paper on it and everything, but
But you're saying
Doing
you're
it finish.
potentially saving millions of dollars to some company?
Well, it depends on the scale that we could get it on as well. So
Yeah.
once we'd be able to prove the concept, you'd have to
But
see
do you
if
feel
you could do
you've
it.
proved the concept already?
Not yet.
yeah, not yet. Like some things did start to come together and work a
The
little
design was, in theory, everything works. In practice, putting it all together is a bit more difficult than.
To be able to do this, did you need a pretty hefty biochemical background?
bit. Not really.
We did this.
We did. I'm from a pharmaceutical background.
Biomed for me.
And
Okay.
yeah.
Yeah.
What kinds of drugs are you making or possibly making?
This technology is for peptide drugs, so drugs that are used for hypertension or like high blood pressure and diabetes and stuff.
We designed it as an example with vasopressin.
Yeah.
So
So this is a really great example because the other thing, to make it more clear, the reason why it costs millions of dollars at the moment is because we use a machine-based way of purifying proteins. Is that correct? That you have gel filtration columns that cost thousands of dollars each to buy. They're really complicated. It takes hours to purify. But with the system that Hewat and Michelle developed, it's much simpler. You just boil it and you get your peptide. And the point of this example is to show some great work from some university students, but also to show this central concept of synthetic biology, that we can find an opportunity in nature, a protein that exists in a bacteria that's evolved to survive at 95 degrees Celsius. We've seen that it could be used somewhere else in a medical application. And this is what synthetic biology is based on. So
I wouldn't be surprised if there's a half a dozen angel investors in this group. Give us your website.
Yeah,
Yeah.
I'm surprised at your lack of ambition. If you're Americans, you wouldn't be here.
I think the thing
this was an
to
opportunity to pitch.
I think the thing to remember here as well is it's not their study, it's not their background. They're not coming from it as a point of view to venture capitalize. They're going, what's an opportunity that can make a difference in the world? And somebody can make an opportunity. If somebody wants to take it and do that, fair enough. But the end goal being a massive return on investment is not always a motivator.
You don't smell big money.
We're not able to, if we put into the registry, patenting is quite difficult, sort of situations. So a lot of the things that we once are in the registry are open for anyone to use, and that's part of the whole iGEM purpose, is sort of so that people can run with it after someone has an idea.
Do you have any kind of commercial background? You know what an IPO and do you know all that stuff?
No commercial background for me.
Regardless of the commercial, if you want to make a difference, and it's a admirable aim, if you don't make a difference, it's not worth doing anyway. You've got to get out there and make a difference.
So what would it cost to finish the work, do you think?
To finish the work?
You
Other
said you're halfway through, I think.
Okay. Well, we're pretty much halfway through. So far, maybe another
Yeah.
10, 15.
Yeah, I was saying before, so far we've used up about $15,000.
Okay.
Chicken food.
Yeah,
So,
so it's not
so
much.
anyone
when
with
you-
$15,000 who wants to get in on a $1 million opportunity,
Going once!
you know who to talk to. So we want to come up with the next $1 million idea. We're hoping to use the minds in this audience to come up with some new ideas